This assignment video is part of our Kumda 610 assignment from the Swinburne and Indy College, and assignment is about tennis scoreboard using the Logisim. So as you can see here, the player one is the original state is the player one serving button is light up, LED button is so when I click the switch server button, then it will switch to the player two button. So when I click again, it will return back to the player one. So this is the I'm using the T flip flop here and constant D as an input. When I click the reset button, it will return back to the player one. So as you can see, when I click the plus button here, it is gonna like increase. That is the so one gain is one for the player one, and then when I click, it also increase and it adds 6 LED, and when I click again, it is gonna like reset to the all then 0. The D flip flop here, with the reset after the when all the LEDs is turned on. So I'm gonna reset it with the reset condition with the all gain, and this is the condition of the stage 2 gain here. So for the stage 3, we how the tennis score works in one game. For example, when you score one, it is your max is gonna increase to the 15 and then 30 and then 40, and 80 is the advantage here. When I increment here, so which is like 15 and the 10, and I increment again, so this becomes 0, 1, 1, which indicates that 40 here. So when I increase it again 100, which indicates the 80. So when I increase here, so like I said, 001, and then when I increase it again, it is become 010, and then increase it again, it become 011, and then 100. And when I increase it again, due to the reset condition of 101, they become 101 here, so it is going to reset it. So and consider D as an input for all then here. So for the stage 4, display the previous the 1 and 0 binary conditions to the 7-segment display, or with the Logisim 5, bring the previous point score output to the new point score display input here with the ln0 to the ln2. The original stage is of course 0, 0. When I increase it here, it's going to become 15. And then when I increase it again, it becomes 30, and then 40, and then 80. So when I increase it again, it is going to become 0, 0. This also works for the player 2 A0 here. So which is normally for the 7-segment, it is count from the clockwise direction from the 0 to the 5, and then 6 here. So for the 0, A is the first letter here. So A is this first letter, and then P is the second letter as I use here. So A0 is counted to the 3 here. 3 indicates this position of the 0 here. This is the A1 here, this is the A2, this is the A3, and so on. And I just connected all to the respective output. So this is out until the output A6, and then starting from the B0 to the B6 here. This is the output conditions that I check out. Of course, 0, 1, 2, 3, 4, 5, and then 6, and we don't use the decimal points here, so we don't need. For the gain score and the point score here, we have to implement the decrement button, and as the decrement button here, it is gonna decrease to the 0, and decrement button must be whatever this the condition here it is. I use a stack asynchronous here for the switch state between the increment and the decrement flip flop here to switch the stage between decrement and the increment here. Control the logic for the clock control here with the NAND gate. And for the reset condition, it is reset after all the 6 LED is light up, or when you press the reset condition here. No error whatsoever. So make use of the D flip flop here, and my score here is the same: 15, 30, 40, and then 80. And when you decrease it, it becomes 40, 30, and then 15, and the same for the player 2. Same logic here, but this time it is just a D flip flop with the output to 0 to the 2 here. So when I increment here, so 001, 010, 011, 100. When I decrement it, it becomes 011, 010, and then 001, and then it all becomes 000. This is for the gain score here with the scenario 1 and the scenario 2. This is for the point score with the scenario 1 and the scenario 2. And I can confidently say that my flip-flop and my circuit has no error whatsoever. So thank you for listening, and that is all for my assignment video.